Okay, let's begin with this then. So in the last session, we covered the concepts that we have in equation of circle. We started with this, that we have this general form for the equation of a circle: x minus a whole squared plus y minus b whole squared equals r squared. If you want to write down the equation of a circle, we just need two things for that: radius of the circle and the coordinates of the center. If we have those two things, we can write down the equation of the circle using those two things. We did a couple of practice questions on that. We also understood how we could go the other way around. If you have the equation given and you have to find the radius of the circle and the center of the circle, we talked about that as well, how you can do that both from an equation in the standard form and in the simplified form. We talked about how we could find the radius and the coordinates of the center from both of these forms. That's what we did in the last session. Then we talked about these angle properties that you also need to know for this topic, because there will be questions in which you will have to use these properties. You need to be familiar with all of them. And then this was one last thing that we did in terms of concepts, and that was, if you have any 3 points on the circumference of a circle, you can find the equation of that circle using this property that we have, that the perpendicular bisector of every chord in a circle, it passes through the center of the circle. So if you have 3 points on the circumference, what you can do is you can make two chords, any two chords using those 3 points. For example, we made chord AB in this case and chord BC. If we can find the perpendicular bisectors of these two chords, the point of intersection of those two perpendicular bisectors, that is going to be the center of the circle. And then once you have the center of the circle, you can find the radius by finding the distance of the center from any of the points A, B, or C. And then you can write down the equation. That's what we covered in the last session. And then we talked about, then we attempted one question from the worksheet as well, and that was question number 2. Now, today we want to do some more practice questions. Let's start with a few from the worksheet. So I will go in order of the questions that are asked here. Question 22. Radius will be half of the distance. No, it would not be half of the distance if we're talking about this example. Once we have the coordinates of the point O, you will find this distance, OB or OA or OC, any of them, they will give you the radius, okay? So it won't be half of that. It's just going to be that distance from O. All right, now let's have a look at some questions from the worksheet. 19 and 22. Okay, so I'll have a look at both of them. I'll do the relatively easier looking one first, and then we will do the more difficult one after that. Okay, so this is 119. Okay, the first one, question number 19. All right, and then we have 22. Okay, let's start with this one, question number 22, and then we do 19 after that. And you can also let me know the other problems that you have. I'm going to start with this one. It's the shorter one and a relatively simpler one as compared to the other one that you asked. Question number 22. Let's start with this. Okay, question 22 from the worksheet. It says, a point A has coordinates 1, 5, and the line L has gradient -2/3 and passes through A. Okay, so line L, it has this gradient and it passes through the point A. And A has these coordinates 1, 5. There's a circle that has its center at 5, 11, and its radius is square root of 52. In the first part, they say, show that the line L is the tangent to the circle at the point A. Okay, now how do we show that line L is a tangent to the circle? Let's sketch this. So whenever you do not have a diagram given, I would recommend that you always draw a rough sketch to try to understand the situation better. So you have a circle. Let's say that circle looks like this. This is a circle. And now let's mark the center of the circle somewhere. Let's say this is the center of the circle. And they are saying the center has coordinates 5 and 11. Okay, so this center has coordinates 5 and 11. Now there's a point A somewhere, which is 1, 5. Okay, now on which side of the center should this point A be? This is something that you should always think of when you're marking points. So you have marked the center of the circle, that is 5, 11. Okay, now there's a point A that has coordinates 1 and 5. Which side of the center should this point be? Let's look at the x coordinate first. Center's x coordinate is 5. X coordinate of the point A is 1. 1 is less than 5. What that means is the point A should be to the left of the center. It should be to the left side. So point A has to be to the left side of the center. Okay, so that's one thing. Then vertically, the y coordinate is 5 for the point A. For the center, the y coordinate is 11. 11 is a bigger number as compared to 5. So 11 should be above 5. So A has to be below the center. So point A has to be to the left side and also below. That means we can mark the point A somewhere on the left side and on the lower side. The point A might be somewhere around here. And there is a line that goes like this from the point A. It passes through the point A. Roughly like this. This is the point L that we're talking about. Right? It has a negative gradient. So we have a negative gradient line that looks like this. The gradient of this line is -2/3. This line is line L. Okay, that's the situation that we have. Now we need to show that L is the tangent to the circle at A. Now I've drawn this assuming that it is the tangent, but how do we prove this? How do we prove that this line L is a tangent to the circle? Now there are two things that you have to prove here. Number one is that this point A, first of all, lies on the circumference. We do not even know that as yet, that the point A lies on the circumference. They've not told us in the question. They have told have they told us anywhere there that the point A lies on the circumference? Let me look at this again. The point A has coordinates this, and line L has this gradient, and line passes through A. So we do not know, it's not given in the question that the circle passes through A. So that's one thing that we have to show, that the point A lies on the circle. Okay, only then the line L can be tangent to the circle at the point A. So the point A has to lie on the circumference. How do you show that point A lies on the circumference? Its distance from the center of the circle, it should be equal to the radius, which is square root of 52. That's one way to think about this. Another way to think about this could be, you could write down the equation of the circle. What's the equation of the circle going to be? X minus a whole squared plus y minus b whole squared. That equals radius squared, which is square root of 52 whole squared. Equation of the circle would look like this. A is 5, B is 11. So this is the equation of the circle. X minus 5 whole squared plus y minus 11 whole squared equals 52. That's the equation of the circle. If the point A lies on the circumference, it should satisfy this equation. Let's check that. Let's input this point A here. 1 and 5. In place of x, you put 1. So you have 1 minus 5 whole squared plus 5 minus 11 whole squared equals 52. Simplify the left-hand side. 16 plus 36, that is 52. 52 equals 52. This shows number one. So that's one thing that you have to show. The point A lies on the circumference. Point A lies on the circumference. This is one way to show this. Another idea could be that you could find the distance of the center from the point A. If that is equal to square root of 52, that would mean that the point lies on the circumference. So either way, you have to first prove that the point A lies on the circumference. Okay, only then you can have a tangent at that point if it lies on the circumference. Okay, now from the point A, you can have many different lines passing. You can have a line passing through A like this. You can have another negative gradient line passing like this. All of these lines are not tangents. When would the line L be a tangent? It would be a tangent if its gradient is negative reciprocal of the gradient of the radius. So this is the radius of the circle. If these two are perpendicular, if line L is perpendicular to the radius at that point, if I call this point O, let's say the center, if line L is perpendicular to OA, that would mean that it can be a tangent because radius and tangent are supposed to be perpendicular to each other. So that's the second thing that you have to prove now, that they are perpendicular to each other. How do you do that? We have the points. Point O is 1, 5. And point A is 5 and no, point A is 1 and point I've mixed this up. O is, I'm calling O as the center. O is 5, 11. And A is this point, 1, 5. These are the 2 points that we have. The second thing that we can do now is we can find the gradient of OA. Gradient of OA, what's that? That's 5 minus 11 divided by 1 minus 5, which is minus 6 over minus 4. That's 3 over 2. Okay, that's 3 over 2. Now you can say 3 over 2 times the gradient of this line L minus 2 over 3. This equals minus 1. That means, number 2, that OA is perpendicular to line L. Both of these things together mean that line L is a tangent at the point A. Okay, both of these things together mean that the line L is a tangent to the circle. Now, some of you might be thinking, or if you're attempted this question already before, you might have thought at first that just proving this, that they are perpendicular, is sufficient. But that's not sufficient, because I can give you an example in which OA would be perpendicular to the line L, but still it would not be a tangent. For example, what if the point A was instead here? That's also possible, right? In that case, the line L would look like this. It passes through the point A. It has gradient minus 2 over 3, and it is still perpendicular to OA. They're still perpendicular. Now, line L and OA, they are perpendicular, but the line L is not a tangent in this case. So just proving this, that OA and the line L are perpendicular, is not sufficient proof for the line L being a tangent. You also have to prove that A lies on the circumference. And that is what we did first there. We proved that the line L touches the circle. That means the point A lies on the circumference. That's what we proved first. So that was one thing that we had to prove. And number 2, we proved that they are perpendicular. Both of these things together, they mean that the line L is a tangent to the circle. Now, that's a general thing that you need to remember. Whenever you have to prove something is a tangent, you have to prove that it touches the circle at some point, and that the radius of the tangent, the gradient of the radius at that point and the gradient of the tangent at that point, they're negative reciprocals of each other. All right. Any problems with this? Does this make sense to everyone? Okay. No questions? Let's look at part 2 now. Okay, good. Part B. Let's look at part B now. Part B says, find the equation of the other circle of radius square root of 52 for which line L is also the tangent at that same point A. All right. Now we have another circle with the same radius. That means it has the same size as this first circle. And that circle also has this line L as the tangent. Now, let me just copy this diagram. This is what the diagram looks like. Now, in this diagram, okay, I'm sorry, I got disconnected. Can you hear me again? You can see my screen again as well? Okay, good. Thank you. All right. So where is the other circle going to be? It's going to be on the other side of the line L, and that will be right here. Okay. That's where the other circle is going to be. That's the only possible position because the radius of the other circle also has to be perpendicular to the line L. One perpendicular could be made on this side. The other perpendicular will have to be on the other side, right? So this is the other circle that we have now. It'll have some center somewhere. We need to write down the equation of the circle. Okay. What do we need to write down the equation of any circle? We need two things, radius and the center. Now we already have the radius of the circle. We know that the radius of the circle is square root of 52. They've already given that in the question. How do you find the center? You have the point O. You also have the point A. That point A was 1 and 5. The point A is 1, 5. We need to find the coordinates of this other point. Let's call this point, let's call that first one O1, then this would be O2. Center of the other circle. How can you find the coordinates of this point? Any idea about this? How can we find the coordinates of this other circle's center? A is the midpoint, right? So since line L is tangent to both of the circles, if we were to extend this line, extend the radius on the other side, A is the center of O1 and O2. A is the midpoint of O1 and O2. You can either use the midpoint formula, that's one idea, or we can use the vector method, that's much quicker, right? Yeah, so just look at the differences between the X and Y coordinates. Let's write that down here. This is how we used to do it. The first point is 5, 11. A is the midpoint, that is 1 and 5. We want to get to the other point. A is the midpoint. So we think of it like this. How many units do you have to go in the x direction to go from 5 to 1? You have to do -4. You do -4 more, and that will give you the x coordinate of this other point. 1 minus 4, that's -3. How do you go from 11 to 5? You have to subtract 6. You subtract 6 more, and that gives you 5 minus 6, which is -1. These are the coordinates. These are the coordinates from for the other circle's center now. Yes, Amna, that's correct. That's exactly what we're doing here. -3, that's the x coordinate, and then -1 is the y coordinate. So we have the center now, and we already had the radius above. We can write down the equation of the circle. We know that this is the standard form: x minus a whole squared plus y minus b whole squared equals r squared. This is the x coordinate of the center. It becomes x plus 3 whole squared plus y minus -1, that becomes y plus 1 whole squared, equals radius squared, that is 52. That's the equation that we were looking for. This is the equation of the other circle that has that same tangent at the point A. All right. Now, they ask this exact same question another way sometimes as well. So they will say, there's another circle such that the line L is the line of reflection of these two circles. So this first circle is reflected in this line L, and you get another circle from that. What would be the equation of that circle, right? So that's exactly the same idea. If this green line was the line of reflection, you would get the same circle. And how do you find the equation of the circle then? Again, you can find the coordinates of the center using the vector method like this. The radius would again be the same, because if it's a reflection, the size of both the figures, it should be the same. So radius should be square root of 52 for that as well. And you can find the equation the same way in that case as well. Okay, I think you might find one question like this in this worksheet as well. Let me see if I can find that. What they talk about reflection. Yeah, so question number 14, part 3 of this. Question number 14, part 3. I'm sorry, something is wrong with it. Okay, part 3 of this, they're saying find the equation of the circle, which is the reflection of some circle in a line. See, exactly the same idea. It'll be the same method that you use in this question as well. Okay. All right. Let's have a look at the next one. Is there any other question before question number 19? Question number 19 is a relatively trickier one. I want to do another simpler one first, relatively simpler one, so you gradually understand the way we are going to approach these questions. Otherwise, that might be a bit overwhelming for some of you. Is there any other question apart from 19? Okay, let me have a look at this. Okay, let's try this one. This is question number 18, and then after this, we do question 19. Okay, let's do this one first. Question number 18, and then we do 19 next after this. Question number 18 from the worksheet. Okay, so we have a circle that has center at the point B, 5, 1. The point A lies on the circle. On the circle means it lies on the circumference. All right. Find the equation of the circle. Now that's really straightforward, the first part. We have the center and there's a point on the circumference. We can find the radius using this information, right? The distance BA would be the radius because B is the center, A is the point on the circumference. That should give you the radius. So we can find radius like this. Radius equals BA. That is equal to square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. 5 minus minus 1, that becomes 5 plus 1 whole squared, plus 1 minus minus 2, that becomes 1 plus 2 whole squared. That's 36 plus 9, and that gives us square root of 45, right? This is the radius, square root of 45. And we know that the center is 5, 1. This is the center, 5, 1. So we have both things that we need to write down the equation. The standard form is x minus a whole squared plus y minus b whole squared equals r squared. Okay, now this becomes x minus 5 whole squared plus y minus 1 whole squared equals r squared, which is square root of 45 whole squared. And that's the equation. You can simplify this to this then, like this equals square root of 45, and that's it. That's the equation that we were looking for. Okay, so that's the first part. That's fairly straightforward. Let's look at the next one. It says point C is such that AC is a diameter of the circle. Point D has coordinates 5, 16, so that DC is a tangent to the circle. Okay, now that's kind of similar to the one that we did before, but now it's a 4-mark question. How do we think about this now? Part B. Point C is such that AC is a diameter. Point D has coordinates 5, 16. We need to show that DC is a tangent. Now, it will become much easier to think of if we draw a sketch of this. Okay, so let's do a sketch. Let's draw a circle. The circle would look like this. So we have the circle. We know the center of the circle. The center of the circle is 5, 1. Let's mark the center. This is the point B, let's say. It has coordinates 5, 1. Okay, so that's one point that we have. The point A lies on the circle. Let me write down the coordinates of A, minus 1 and minus 2. Okay, so I'll let all of you think about this. To which side of the center is this point A going to be? Which side of the center is the point A going to be? Left or right, up or down? What do you think about it? Where should I mark A on the circumference? Should I mark it here, 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 here? What do you think? Bottom left, right? How do we know that? X coordinate is 5 of the center. For A, it's minus 1. So the X coordinate of A is smaller. That means it should be to the left. Y coordinate is also smaller than the Y coordinate of the center. It should be below. So we can mark the point A somewhere on this side. Now, even though you can still get the correct answer using calculation, even if you were to mark this point A on another side, but this would make it much easier to understand what to do in the next steps if you mark these points accurately. So I would highly recommend that you draw these diagrams slightly accurately, in the sense that the points should be in the correct direction. Okay, so you should know that if you have center somewhere, then the points that you're marking, whether they are on the left or right or up or down, and that will make it much easier for you to understand the next steps after that. Now we have this point A. We know the coordinates of the point A are minus 1 and minus 2. Let me just write them down here, minus 1, minus 2. Now they're saying C is such that AC is a diameter. So there's some point C somewhere such that AC becomes the diameter of the circle. Where's the point C going to be? If AC is the diameter, it's going to look like this. It will be on the other side of the center. This point here is C. Now, we don't know what the coordinates of C are yet, but we can find them if we need to. But let's see what they're asking for next. There's a point D somewhere that has coordinates 5 and 16. 5 and 16. Remember, what was the radius of the circle? Do we know that? Radius was square root of 45. That was the radius. That's like 6 point something. I think 6.7, 6.8. Square root of 45. Yeah, 6.7. That's the radius. Okay, keep that in mind. There's a point D now. 5 and 16. Where should I mark that point? Is that point inside the circle or outside the circle? What's the x coordinate? X coordinate is 5. What's the x coordinate of the center of the circle? That's also 5. What does that mean? If this is x equal to 5, the point D is also going to be on this same line. Okay. It's going to be on the same line. It's going to be somewhere on this line. Since the y coordinate is bigger than 1, it has to be above the point B. Okay? So it'll be above the point B somewhere. Now, is it going to be inside the circle or outside the circle? This is 1, this is 16. What's the difference between these two values? 15. That's much bigger than the radius. That means the point D is going to be way outside the circle. It might be somewhere here. Let me just mark that outside. The point D is going to be somewhere outside, like this, for instance. This might be the point D. Okay? And this point D has coordinates 5 and 16. Remember, it's exactly above the point B. It's exactly above the center of the circle, like this. So this is what your diagram looks like now. Okay? This is what the diagram looks like. We need to prove that DC is a tangent to the circle. Now, how do you do that? One thing, we need to show that point C is on the circumference. Do we need to show that, or do we know that in this case? We know that because AC is a diameter. Since AC is a diameter, that means C has to be on the circumference. That's not something that we need to prove this time. In the previous question, we had to prove that. But in this case, we don't have to prove that. We know that it lies on the circumference. So all we need to do now is we need to show if DC is a tangent, we need to show that if we were to draw a line like this, does not seem that accurate, but if we were to draw a line like this, then this line should be perpendicular to the radius. That's what we need to show. Okay. Now let me change this slightly so that it looks a bit more accurate. Let's take A here, and then this here. Let's say this is the point C, and now that might look like a tangent. Yeah, so roughly that makes sense now. DC. This is the line that we have. How do we show that this is a tangent? We have to show that this angle is 90 degrees. How do we show that these two lines are perpendicular? We would need, if we want to find the gradient of BC and CD, we need the point C first of all. How do you find point C? Can we find the coordinates of the point C somehow? AC is the diameter, right? That means B is the center, B is the midpoint of A and C. Again, we can use the vector method. We have the point A. The point A is -1 and -2. We have the point B, which is the midpoint of A and C. And you can find the point C using the vector method. We have to do +6 here to get to B. We do +6 more, and that gives us 11. From -2 to 1, we have to do +3. We do +3 more, and that gives us 4. These are the coordinates of the points C, 11, and 4. And now what you do is you find the gradient of CD and see what that turns out to be. 16 minus 4 divided by 5 minus 11. This is going to be 12 over -6, which is -2. And then you find the gradient of the radius, gradient of BC. Let's see what that is. 4 minus 1 divided by 11 minus 5, and that's 3/6, which is 1/2. And that proves that they are perpendicular. You can either write in words that these gradients are negative reciprocals of each other, or you can do something like this. You can say -2 times 1/2. This gives us -1, and that proves that CD is perpendicular. CD is perpendicular to BC. That means this is a tangent. Let's write it the other way around. BC is perpendicular to BC. That implies that DC is a tangent. And that's what we had to do in the second part. That proves that DC is a tangent to the circle. Does this make sense? So we found the point C first of all, and then we just found the two gradients. Since they're negative reciprocals of each other, that means that it's a tangent. Now, what about part C, the next one? It says the other tangent from D to the circle touches the circle at E. Okay, so from D, this is one tangent that we have, DC. We can draw another tangent from D as well. Where would that be? That would be on the other side of the circle, like this. Right? That would be the other tangent. They're saying it touches the circle at the point E. Find the coordinates of the point E. Now, where would that point be? Notice the symmetry of this diagram now. Now, this is why drawing good diagrams is extremely important in this, because now that you know that D is exactly above the center, D is exactly above the center. The symmetry of the figure tells you that this point E is going to be at the same level as the point C, right? Wherever C was, E is going to be at the same horizontal level, right? Another way to think about this is, remember the shape that you get in this case? If you join E with the center of the circle as well, this is a kite, right? It's a kite-like figure always. And we know in a kite, the diagonals, they are perpendicular to each other, right? That's a property that we did in coordinate geometry earlier. In a kite, the diagonals of a kite are perpendicular to each other. That means this is a 90 degrees angle. If this is the 90 degrees angle, since we know that BD is vertical, BD is vertical, right? Because they have the same x coordinates. Perpendicular to a vertical line is the horizontal line. So EC is going to be horizontal. And that tells you that the coordinates, the y coordinate of the point E, therefore has to be 4. We don't have to do any calculation for that. We can just write it directly that the y coordinate of the point E, it has to be 4 because they lie on the same horizontal line. Okay? So the y coordinate has to be 4. Right? They have the same y coordinates. Now the question is, how do you find the x coordinates? How do you find the x coordinate? Any idea about that? We are looking for the coordinates of the point E, right? So we have the y coordinate, that is 4. What about the x coordinate? Radius? What do we do about the radius? We know that the radius is square root of 45, right? Okay. How does that help? So this is also square root of 45. Okay. Then we don't actually have to do any calculation here. As in no complicated calculation, at least. This is point B. It has coordinates 5 and 1. Look at this point where the diagonals of the kite, they're intersecting. This is also going to have the same x coordinate. It's going to have an x coordinate of 5 as well. What about the y coordinate? It's at the same level as the other points. This point here is going to be 5 and 4. The point of intersection of the diagonals. And then all you have to do is look at how many units point C is from this point. So it's from 5 to 11. This length is 6 units. So on the left side as well, this length should also be 6 units. So this is 5. You subtract 6 from that, and the x coordinate here turns out to be -1. You're asked to find the coordinates of E here. It's a 2-mark question. The 2 marks that you have there, they're only for these coordinates. You can write down the coordinates directly without any working. 1 mark is for the x coordinate and the other mark is for the y coordinate. Yes. So 11 minus 5, that gives us 6 units. We go 6 units to the left here, and that gives us the x coordinate -1. These are the coordinates of the point E, and that's all that we have to do. We just write down those coordinates here. Part C, the point E is -1 and 4. And that's what we were looking for. All right. Does this make sense to everyone? Okay, let's move on now to the next one. This was 18. Let's do 19 now. And then maybe one more after that if we have time. Let's do question number 19. Okay, so we have a center with center C that has equation x minus 8 whole squared plus y minus 4 whole squared equals 100. Show that the point T is outside the circle. T is outside the circle. Any idea about this? How do we show that T is outside the circle? How can we show this? Put x and y in the equation. Okay. So you are saying that you put x and y in the equation. -x minus 8 whole squared plus y, which is 6, minus 4 whole squared equals 100. And that gives you 14 squared, which is 196 plus 4. That gives you 200 equals 100, which is obviously incorrect. Does that prove that the point T lies outside the circle? Yes. Does it prove that? Does everyone agree to this? If they're not equal, does it mean that the point lies outside the circle? Is that sufficient proof? Remember, the equation represents points on the circumference. The equation represents points on the circumference of the circle. If a point does not satisfy the equation, yes, one possibility is that it lies outside the circle, but it could also be inside the circle, right? Because the points inside the circle, they also would not satisfy the equation of the circle. So if it's not equal, if they're not equal, that just proves that the point does not lie on the circumference. It could be inside, it could be outside. Okay. Now, one idea could be that you clearly say that 200 is greater than 100. That means it lies outside the circle. If this number was less than 100, that would mean it lies inside the circle. But that's a bit, that's going to confuse some people. I would recommend that you think of it this way. X minus 8 whole squared plus y minus 4 whole squared equals 100. That's the equation of the circle that we're given. Can we find the radius of the circle? Just compare it with the standard form. This is r squared. From this standard form, we are getting r equal to square root of 100, which is 10. Radius of the circle is 10. What about the coordinates of the center? They are going to be 8 and 4. Right? You flip the signs, it becomes 8 and 4. These are the coordinates of the center. Now, if the point T, okay, center is C, let me call this C. C is 8, 4. If the distance of point T from C is greater than the radius, if there's some point which has a distance more than 10 from the center, that would mean that that point lies outside the circle. And if there's a point that has its distance from the center less than 10, that would mean that that point lies inside the circle. And if the distance is equal to 10, that means it lies on the circumference. So what we do is we find the distance CD, distance between the 2 points C and D. How do you do that? Using the distance formula. X2 minus x1 whole squared, we can say 8 plus 6 whole squared plus 4 minus 6 whole squared. And that gives us square root of 200, which is 14 point something. Square root of 200, 14.14. Distance of center from T is 14.14. That is greater than the radius. CT is greater than the radius. That means that T lies outside the circle. Okay. Since the point T has a distance that is greater than 10 from the center, it means it lies outside the circle. If this distance was less than 10, that would mean it lies inside the circle. That's the first part. Yes, you can do the first method as well, but just not equal to would not be sufficient. You would have to clearly say that 200 is greater than 100. You will clearly have to write this. And then that proves that it's outside the circle. Okay. Not equal to does not prove that. Okay. Because not equal to means it could be inside the circle as well. You have to clearly say it's greater than 100. Okay. Now that's part A. What about part B? Two tangents from T are drawn to the circle. Show that the angle between one of the tangents and CT is exactly 45 degrees. Okay, now how do we think about this? Again, I would recommend draw a diagram, and that will help you understand this better. Draw a rough sketch. So let's say we have a circle that looks like this. Okay, so this is a circle that we have. There is the center of the circle here. It has coordinates 8 and 4. This is point 8 and 4. T is outside the circle. We have proved that in the first part. Where exactly is this point T going to be? What are the coordinates of T? The coordinates of T are -6 and 6. Right? -6 means it is going to be on the left side of the center, right? This is 8. This is -6. It should be to the left. 6 is bigger than 4, so it has to be above. But see, the distance of the x coordinate is much more than the distance between the y coordinates. So it's more to the left than it is above. So it's slightly above the center. And then outside the circle, it might be somewhere around here, let's say. So let's mark this point here. Because remember, the radius of the circle is 10, right? So with respect to that, it's just 2 units above. So it might be somewhere here. Again, you don't have to be very accurate, but as much as is easily possible without spending too much time on this. This is where T is roughly going to be. It has coordinates -6 and 6. That's the situation. Now, two tangents from T are drawn. They're saying two tangents from T to the circle are drawn. Where are those two tangents going to be? One on the upper side and one on the lower side. This is one tangent. And then this is another tangent. These are two tangents that we have. Okay. Show that the angle between one of the tangents and CT is exactly 45. CT, what's CT? C is the center of the circle. So if you were to join C and D, it would be a line that looks like this, CT. We need to find that we need to show that the angle between CT and one of the tangents, so either this tangent or this tangent, that angle is 45 degrees. So we have to find one of these two angles. How can we do that? What information do we have? We can make a right angle triangle. Remember, it always helps in problems like these. When you have two tangents coming from outside the circle, I would recommend you always make a kite-like figure. And then think of it using that. You have a right angle here. The radius is 10. And this side, CT, we've already found that before. CT distance, that is square root of 200. This is square root of 200. Right? We are looking for this angle. So we have a right angle triangle. We can use basic trigonometry. Let's call this angle theta. How do you find this angle? You can use perpendicular and hypotenuse. You can use sine for this. Sine of theta equals opposite over the hypotenuse. And that would give you the value of theta. You can see what that is. Sine inverse of 10 over square root of 200. And this gives me 45 degrees. And that's what we wanted to prove. The angle between CT and one of the tangents, that is 45 degrees. All right, that's part B. You could make this right angle triangle below as well, and that will give you the same result. That's also 45 degrees. Okay, so that was part B. Let's look at the next one now, part C. The two tangents touch the circle at A and B. The two tangents touch the circle at A and B. So we have one point A and the other point B. We do not know which one of them is A, which one is B. So we can mark any of them as A and any of them as B. Let's say this is A and this is B. All right. Now, find the equation of the line AB, giving our answer in the form y equals mx plus c. We are looking for the equation of this line AB. Let me draw it like this. This is the line AB. We want to find the equation of this line. How can we do this? How can we find the equation of this line? That's the question now. Any idea about this? It's a straight line. For a straight line, we need two things. We need the gradient, and the other thing, we need a point. Gradient we can find easily. Why? Because we know it's a kite, right? It's a kite, and we know that the gradient, the diagonals of a kite, they're always perpendicular to each other. So we are going to have a 90 degrees angle here. We're going to have a right angle here, right? We've done this property before in coordinate geometry. Diagonals of a kite, they are perpendicular to each other. Okay, diagonals are perpendicular to each other. So that means we have a right angle here. So if we can find the gradient of CT, we can just take negative reciprocal of that, and that will give us the gradient of AB. So that's one thing sorted. Gradient of CT, let's find that. Y2 minus y1, that's 4 minus 6 over x2 minus x1, that's 8 minus 6, that's 8 plus 6, minus 2 over 14, which is minus 1 over 7. That's the gradient of CT. What about the gradient of AB then? It will just be negative reciprocal of that. Gradient of AB, that would be 7. That's one thing sorted. So we have the gradient of the line AB. But now we need one point on the line AB. Do we have any point? And if we don't, how do we find that one point? How do we find that one point? Midpoint of T and C, Y. How can you be sure that this point of intersection is the midpoint? How are we sure about that? How do we know that? Do we know that AB passes through the midpoint of CD? It's a kite, right? That's all that we know until now, that it's a kite. And if it's a kite, it's the diagonals do not necessarily meet at the midpoints. Yes, this point is going to be the midpoint of AB. It is going to be the midpoint of AB, but not necessarily the midpoint of TC. Can we somehow show that it is going to be the midpoint? Is there a way to do that? Let's think about that. We have already proved that this angle is 45 degrees, right? They made us do that in the previous part. If this is 45, then this is also 45. What does that make this total angle? This complete angle becomes 90 degrees. So we have a right angle here. The other two were, the two other angles were already right angles because this is radius and tangent. This is also radius and tangent. These two are already perpendicular. That means the last remaining angle here, it is also supposed to be 90 degrees. All of these angles are 90 degrees. This length is 10. This length is also 10. So it's a kite in which the adjacent sides are both equal and the angles are all 90 degrees. What does that make this quadrilateral? It's actually a square, right? It becomes a square because all angles are 90 and adjacent sides are equal. The opposite sides are also going to be equal for that reason. This particular diagram, in this specific question, it becomes a square. ACBD is a square. Okay, because the angles are all 90 and the lengths are all equal. In a kite, adjacent sides are supposed to be equal, right? So if these two are equal, then and the angles are 90, then that makes the other sides also 10. So that makes it a square. Since it is a square now, we know that in a square, diagonals always meet at the midpoint. And in a square, the diagonals are perpendicular bisectors of each other. So the line AB is actually going to be perpendicular bisector of TC. That tells us that this point where AB intersects CT, this point, if you call this M, it is supposed to be the midpoint of CT. You cannot assume that, right? You have to clearly show that it's a square. Write down that it's a square. Since it is a square, this point is the midpoint. Okay? You don't have to give reasons, but you have to give reasons to yourself at least, right? Because otherwise you would end up making a wrong assumption sometimes. Okay? So you cannot guess like that. You have to be sure about it yourself that it is a square. That is why it is supposed to be the midpoint. Because if it was not a square, then this point would not be the midpoint. Okay? So that's why it's important to understand that it is a square. That is why it is the midpoint. And now we can find that midpoint of TC. Midpoint of CT, what's that? Minus 6 plus 8 over 2 and 6 plus 4 over 2. That gives us 1 and 5. That's the point that we were looking for. Now we have a point for on the line and we have the gradient. We can use these two things to write down the equation of AB. What would that be? Y minus y1 equals m into x minus x1. Y minus 5 equals m, which is 7 into x minus 1. That's the equation that we were looking for. And that's our final result. Okay, that's not the final result because they want us to write the equation in y equals mx plus c form. Let's simplify this. It becomes y equals 7x minus 7 plus 5, which gives us y equals 7x minus 2. And that is your final result. This is the equation of the line AB. That's part C. Now, let's look at the last one quickly. Now they say, find the x coordinates of A and B. X coordinates of the points A and B. Now we have to find these points. The x coordinates. How do you find them? A and B are the points of intersection of the circle and the line AB, right? A and B are the points of intersection of the circle and the line AB. So all we have to do is solve them simultaneously. Equation of the circle and equation of the line AB. So we have the equation of the circle already given. X minus 8 whole squared plus y minus 8 4 whole squared. That equals 100. That's the equation of the circle. Equation of the tangent, equation of AB is y equals 7x minus 2. A and B are points of intersection of these two functions, of these two equations. You just solve them simultaneously. Since we're looking for only the x coordinates, we can eliminate y. We already have y equals 7x minus 2 here. We just put that in the other equation. You put y equals 7x minus 2 here, and that gives you x minus 8 whole squared plus 7x minus 2 minus 4 whole squared equals 100. X squared minus 16x plus 64 plus 7x minus 6 whole squared. Let's bring 100 to the left side as well, equals 0. Let's simplify this further. X squared minus 16x plus 64 plus 49x squared minus 2 into 7 into 6. That's 42 times 2, which is 84 times x, plus 36 minus 100 equals 0. 64 minus 36, 64 plus 36 and minus 100, they get cancelled. And we have x squared plus 49x squared, that is 50x squared, minus 16 minus 84, that is 100x, that equals 0. We can take 50x common outside, that leaves us with x minus 2 inside, which means either 50x is equal to 0 or x minus 2 is equal to 0, x equals 0 or x equals 2. These are the coordinates of A and B, the x coordinates of A and B that we were looking for. Now, we do not know which one of them is A and which one of them is B. So we just leave it like this. One of them is going to be 0 and the other is going to be 2. These are our final results, x equals 0 and x equals 2. All right. Any problems with this? Any questions, anyone? No? All right, good. So that's it on equation of circle then. You might find another good question in recent papers. I just thought of that. So you will find questions like these, I think 1 or 2 in the last 2 years, where they have a circle and there is, they say something like this, that a line meets the circle at one point. Okay, there's a line that meets the circle at just one point, or the line is a tangent to the circle. In that case, that should remind you of something that we did in quadratics earlier. That when you have a line that meets a curve at just one point, b square minus 4ac is equal to 0. So sometimes you have to use discriminant in circle equations question as well. Keep that in mind. You will find that in one of the recent papers when you're practicing more. Just remember that that's what you have to do in those questions. If a line meets the circle at one point, or the line is a tangent to the circle, that means b square minus 4ac is equal to 0. Yes, Samna, we will be starting yearly past papers around 7th, 8th of April, inshallah. Okay, so until the exam night, the night before exam, we will continue with yearly past papers once we're done with the syllabus, inshallah. So they will start once we're done with M1 and S1, that will be around 10th of April, but I'll start the yearly past paper session alongside by around 7th or 8th of April, inshallah. Okay, so that will start at that time. Okay, so now we have two topics left after this: binomial expansion and arithmetic and geometric progressions. I want a quick opinion from you guys. We need to spend 4 classes in this now. So we have 2 left in this week, but we will need to spend 2 more classes after that. We need 2 for AP-GP and 2 for binomial and binomial expansion. Now, one idea is that we complete AP and GP concepts tomorrow, and then we do practice questions on Thursday on AP-GP. And then for binomial, we do binomial sometime next week or the week after that. We will figure out some time for that, and then we'll do binomial. That's one idea, that we do AP-GP concepts tomorrow and then practice questions on Thursday. The other idea is that we cover the AP-GP concepts tomorrow, and then on Thursday, we cover the binomial concepts. Okay, so that we're done with all the concepts at least, and then we'll have time for practice as well. And then we can have some practice class for AP-GP at some point next week, and another for binomial practice maybe next week as well, or the week after that. So the 2 options are, we just do AP-GP tomorrow and Thursday, and on Thursday, and then do binomial later on. And the other idea is we do AP-GP and binomial concepts tomorrow and then leave practice for later. Which one of them would you prefer? Let me ask you to raise your hands. Let me just lower hands. Matt, just give me a second. I'm sorry. Can you lower your hand right now? Okay. So how many of you would, what I'll do is, since there are many people who are not here in the class right now as well, what I'll do is I'll post it in the group. I'll post a poll on the group. Please vote on that as soon as possible so we can decide what to do in the next 2 classes. I'll post a poll and then you can respond to that on WhatsApp. Okay. But I've explained to you the 2 options that we have. I'll do a poll and you can respond to that. I'll see you again in the next class then. That's tomorrow. Mehed, you have a question, you can stay back. Everyone else, you're free to leave. I'll see you again tomorrow, inshallah. Allah Hafiz. Yes, Mehed.
Assalamualaikum. Sir, मैंने आपसे क्वेश्चन पूछना था. It's about SAT. तो मैं ना SAT, it's on Saturday and मैं अभी तैयारी कर रहा हूँ. I am doing practice tests. तो मेरे scores math.
अच्छा Mehed, एक मिनट. Sorry, I got distracted. Could you please start over again? Yes.
हाँ सर, मैं कह रहा हूँ कि मेरा ना SAT है this Saturday. I am doing a couple of practice tests and मेरे math में ना मेरा score 600 तक आ रहा है. It's not crossing 600 right now. तो मेरा जो इशू है ना, इट्स के मैं टाइम मैनेजमेंट अपने सेकंड मॉडल में ठीक नहीं कर रहा, बिकॉज मुझे कोई कॉन्सेप्ट्स नहीं आते. सेकंड मॉडल में देयर इज वो प्रॉब्लम सॉल्विंग एंड डेटा एनालिसिस वाला सेक्शन जिसके ऊपर मेरे मार्क्स मोस्टली कट रहे हैं, एंड देन देयर इज लाइक अ कपल ऑफ ट्रिग्नोमेट्रिकल एंड फंक्शंस रिलेटेड जो कॉन्सेप्ट्स हैं उनके ऊपर मेरे मार्क्स कट रहे हैं. इन 3 कॉन्सेप्ट्स के ऊपर आई एम लूजिंग माई मार्क्स. तो मैंने आपसे पूछा था कि डू यू हैव एनी लाइक एडवाइस फॉर लाइक द सैट मैथ पोर्शन?
सैट का ये कि एक दफा आप अपने कॉन्सेप्ट्स पूरे कर लो ना एक दफा, तो उसमें फिर जो इजी और मीडियम लेवल डिफिकल्टी लेवल वाले क्वेश्चन होते हैं वो तो आप सारे आराम से कर लेते हो. इफ यू आर सेइंग यू आर स्ट्रगलिंग विद सम कॉन्सेप्ट्स, आपने अगर सारे पूरी तरह से कॉन्सेप्ट्स सारे कवर नहीं किए और आपने ज्यादा प्रैक्टिस पे फोकस किया, आई वुड रिकमेंड कि वो जो कुछ कॉन्सेप्ट में आपका मसला हो रहा है एक दफा कॉन्सेप्ट कर लो, बिकॉज बहुत ज्यादा ना रेपिटेटिव है सैट. आप एक दफा वो सारे कॉन्सेप्ट्स कर लोगे, इट्स very similar questions that you see again and again and again, except for some harder questions जो दोनों मॉड्यूल्स में लाइक 3-4 ही होते हैं मैक्सिमम, ज्यादा जो है वो मीडियम डिफिकल्टी लेवल होते हैं. तो अगर आप वो कॉन्सेप्ट एक दफा पहले उस पर फोकस कर लो, जो जिन पे भी आप स्ट्रगल कर रहे हो, अगर आप फंक्शंस में कहीं पर मसला आ रहा है, डेटा इंटरप्रिटेशन में कहीं पर मसला आ रहा है, डेटा इंटरप्रिटेशन में ज्यादा प्रैक्टिस है वैसे, उसमें ज्यादा इन टर्म्स ऑफ कॉन्सेप्ट थोड़ी सी ही चीजें हैं, बट फंक्शंस में आपको कॉन्सेप्ट्स एक दफा सारे कवर करने चाहिए. You might, आपने YouTube पे मेरी प्लेलिस्ट देखी है सैट वाली?
नहीं सर, मैं अभी सिर्फ खान अकेडमी यूज कर रहा हूँ. आई एम ट्राइंग कि मैं ज्यादा रिसोर्सेज अभी यूज ना करूँ.
आप कॉलेज पांडा की बुक है आपके पास?
नहीं सर, मेरे पास नहीं है. मैं सिर्फ ऑनलाइन ही पढ़ रहा हूँ, जस्ट खान अकेडमी, एंड देन जो भी क्वेश्चन बैंक्स वगैरह मैं सारे ऑनलाइन ही देख रहा हूँ.
अच्छा चले, अब तो 3 दिन है, तो 3 दिन में बहुत ज्यादा तो आप उस तरह नहीं कर सकते, बट आई वुड
हम्म।
हाईली रिकमेंड कि आप एक दफा ना कॉन्सेप्ट्स जल्दी से गो थ्रू कर लो एक दफा,
हाँ
जिसमें
हाँ।
जिन कॉन्सेप्ट्स में आपको जिन जिन सेक्शंस में आप ज्यादा मार्क्स लूज कर रहे हो, उनके कॉन्सेप्ट जरूर एक दफा कवर कर लो, बिकॉज अदरवाइज आप वो सेम मिस्टेक्स बार बार करोगे अगर आपके कॉन्सेप्ट ही वो सही नहीं है तो। उसके
हम्म।
लिए आइडियली दिस इज योर फर्स्ट अटेम्प्ट राइट?
हाँ, so ये पहली अटेम्प्ट, आई एम जस्ट गिविंग इट फॉर प्रैक्टिस।
अच्छा ठीक है, सो यू शुड डेफिनेटली गो थ्रू अ बुक इन डिटेल। कॉलेज पढ़ना इज व्हाट आई वुड रिकमेंड। उसी बुक पे बेस्ड मैंने वो पूरे एक सारी अपलोड भी की हुई है, तो आप वो बुक से एक दफा सारा कवर कर लो। अगर उसमें किसी कॉन्सेप्ट में मसला आता है तो आप उससे रिलेटेड वो वीडियो देख सकते हो। बट अब इस टाइम के ऊपर यू हैव टू बी एफिशिएंट, जस्ट आप उस उन कॉन्सेप्ट पे फोकस कर लो जिनमें आपको मसला हो रहा है। कॉलेज पढ़ने का आपको मिल जाएगा ऑनलाइन भी वर्जन, ऑल दोस डिजिटल सैट का एक नया वर्जन भी आ गया हुआ है।
हम्म।
वो आप एक दफा अ, ये वाले स्पेसिफिक कॉन्सेप्ट उससे जरूर गो थ्रू कर लो।
हम्म।
ठीक है, अदरवाइज फिर आप वो सेम
थैंक यू
मिस्टेक्स
सर।
बार बार कर रहे होगे।
हाँ हाँ, ठीक है, थैंक यू सर, और सर रमजान मुबारक।
खैर बार, ठीक है, ये चाहते हैं।
Sir, I just wanted to say that there was like stuff going on in my family, so I was unable to